Okay, with that, we'll go ahead and kick off today's webinar, which is making the business case for DevOps and CI/CD. Our speaker today is Dan Garfield, who is the Chief Technology Evangelist at CodeFresh. Hi, Dan, welcome.
Hello, glad to be here.
Great.
Well, I am excited to get started. This one's going to be very different because it's actually more about the value of doing DevOps, the value of using good CI/CD, and how you communicate the investments that you want to make to your business in a way that they can understand. So with that, I'll give a very quick introduction to myself. As Shirley mentioned, I am Dan Garfield. I'm the Chief Technology Evangelist for CodeFresh. I am a Google developer expert focused on cloud, Kubernetes, cloud native, Docker, continuous delivery, all those kinds of things. I'm also a Forbes Technology Council member. And I do, in addition to my sort of evangelism work on behalf of CodeFresh, and part of that, I do a lot of workshops at Fortune 1000, Fortune 500 companies on adopting cloud native technology, kind of streamlining the CI/CD processes, those kinds of things. So this is something that I actually do quite often, sort of professionally, and so now I'm going to share with you some of the things that I've learned over the years for communicating with people. So to jump right in, and kind of the reason that CodeFresh is involved in this is because if you look at the software development process, from the moment you write code to the moment it's deployed, there's this critical loop that you do over and over and over again. If you do it really, really well, you can be incredibly successful as a business. If you do it poorly, you lose a lot of value. So CodeFresh is basically focused on that area. It's a CI/CD platform. So this is why I am so focused on it and why I deal with it so much professionally. So that's the intro to who we are, just very briefly. Now, the big problem that I often see is that the engineering organization and the business organizations often don't speak the same language. And one of my favorite examples of this is there's this old thread, classic story about a guy who quit Google after 4 years, and he, not to pick on Google, but he had some bad experiences with communicating business value. So one of the things that he was responsible for was a data pipeline. And one of the first things he did is he came in and found that no one had written tests for it. And so stuff was breaking all the time. People didn't know about it. So he actually wrote tests and created a way so that people could capture errors. And this seems like a really great idea for those of us that know engineering. We're like, hey, this is great. We're gonna find all the errors so we can go and fix them. This is wonderful, right? Well, when it came time for his performance review, he said, I couldn't prove that anything I did had a positive impact at Google. My bug discoveries caused the overall bug count to increase. In other words, people took the numbers and they said, you know, you've been working on this project for 6 months and we've only got more bugs. So seems like you must be doing a bad job. So this is this is an example of sometimes numbers being used against you. So if you don't know how to communicate this stuff effectively, if you don't know how to speak the language of business, so to speak, which is usually in terms of revenue or dollars, costs, those kinds of things, then you're going to fall on deaf ears. So that's what we're going to focus on today. I do want to issue a little bit of a disclaimer beforehand. Now, we're going to put cost estimates to a lot of things that are hard to estimate, and your mileage will vary depending on your business, depending on what makes sense for you. You always want to gut check your numbers and make sure that they're going to line up with business expectations. And so if you say, for example, if you run these calculations, they're only as good as the inputs, right? So if you come to the end and you say, well, our company makes $10 million a year, and by improving our uptime, we will gain an extra $100 million in value. Well, you probably need to double check your inputs because no one's going to buy it, right? But engineers sometimes struggle with the concept of business numbers because lots of times in business, you're dealing with so many unknowns that you have to make estimates. You don't always know the answer, and sometimes getting to the answer is actually so costly that it's better to take a guess and run after it. So as we get into the numbers portion of this presentation, I'm very happy to have feedback. If you have different experiences that I'm presenting here, please share those, and maybe I can refine the presentation even further for those that get it in the future. But in the meantime, you know, feedback is welcome, and I'll share sources when I have sources, and I'll share assumptions when I have assumptions, and I'll share kind of how we got to some of these numbers as we go through and actually get into the dollars and cents portion of this thing. So we're going to talk about the DevOps stuff, and basically we're going to go through 4 different ways that DevOps provides value. And this will give you a chance to, I think these are 4 areas of value that you should focus on when you're talking to the business and explaining to them what it is that you do, what it is that DevOps does, why you should be investing in it. We're also going to talk about calculating actual dollar savings or dollars added to the business, and different inputs you can use for that. We're going to talk about a couple of tools that can help you in this, and we will kind of close on a build versus buy, because this is actually one of the most critical decisions that people make, and they often miss a lot of the costs involved. And so we'll get into that. As always, as we go through this, feel free to throw questions into the comment, use the chat. Very happy to see that as I'm going along. It lets me know that you're interested in what's happening, and I'm happy to answer questions. To answer the first question, are you muted? The answer is no, I'm not muted. So we'll move on from there. All right, so DevOps basically breaks down into 2 areas. You have productivity engineering and you have site reliability engineering. Now, not every organization splits it up this way, but when I think about the metrics conceptually, they actually fall into these 2 buckets. You've got productivity engineering, which is thinking, how do I make my engineering team more successful, more productive, deliver faster? And you've got your site reliability engineers thinking, how do I make sure this thing doesn't fall down? How do I make sure that we have great uptime? And these are in a unique push and pull relationship. Now they have some unique different metrics. Whoop, excuse me. You have some unique different metrics for these. On productivity engineering, you're thinking most often about change lead time. That is, how long does it take you from the moment you start writing code to actually deliver the feature? Your deploy frequency. So how often are you deploying? Is it several times a day? Is it once a quarter? Your productivity engineering is basically going to be measured primarily in those 2 things. On the site reliability side, you're going to be thinking about your change failure rate. So what percentage of the time when you deploy does that lead to a failure? Now, we also look at mean time to recover. So in the event of a failure, how long does it take you to come back? And what's your uptime overall? And basically, if you look at the business translation for these things, productivity engineering, the business translation is engineering is fast. We're fast. We can be agile, we can be quick. And on the site reliability engineering, we're going to sell more if the website works. We know as a business, if Netflix is down, Netflix is not making money, right? So that actually is the first area of business value we're going to go into. It's one of the easiest to explain, I think, and then we're going to get into what I think are actually the more interesting areas of value. So number 1 is avoiding downtime. Now this should be classic and easy to understand for everybody. There have been quite a few high-profile downtimes. There was just recently, I hate mentioning names because I don't want people to feel like I'm picking on them. If one of you is in the audience who's from one of these companies, know I love you. And we had a competitor at CodeFresh who had an outage, and it was they actually lost user data. It was a big thing. We sent them cookies and donuts to their office. We were like, good luck, get this worked out. We hope you can. We're rooting for you. Even your competitor, you don't want to see downtime. So Costco over Thanksgiving, over Black Friday, had an outage, and they lost about $11 million worth of business. So that stunk. And then Amazon had just recently, a few months ago, they only had about 13 minutes of downtime. But when you're Amazon, that means you lost over $2.5 million. So that's a bummer. Don't want to lose that money. Southwest had a famous one just a few years ago where they had about a whole day outage, and it cost them nearly $82 million when everything was said and done. Not only in lost time, but in lost travelers and people who couldn't travel, and misconnections and insurance payments and all those other things. So we know that downtime is very expensive. And one of the things that I think is not intuitive when you're thinking about downtime is from a business perspective. When a business looks at their expenditures, they want to know, how do each of these things contribute to my revenue? And normally revenue is thought of essentially as inputs from the sales team, from your engineering team, and from your marketing team. These three teams, and you've got partners and some other teams in there, but it's just kind of just a general, guideline. When all of those three components are working together, you can have good revenue. You're making money as an organization. So you're essentially within this, you have your product is functioning, your sales machine is functioning, all those kinds of things. Well, the problem is that if you think about it, these are all legs of a stool. So if we take engineering out, the site's down, right? All of our technology stack is down. Well, the stool's going to fall over. So the value of downtime is basically whole revenue. It doesn't matter how good sales and marketing is. Now, this might depend on your business. If you're selling tractors, maybe it's not a big deal to have a little bit of downtime, but it probably is. If sales can't do their job, they can't sell, they can't make the money. Maybe sometimes you get some revenue delays or things like that. But in general, if engineering doesn't work properly, then everybody's in trouble. If marketing doesn't work properly, everybody's in trouble. If sales doesn't work, everybody's in trouble. So basically, the calculation for uptime and the value is fairly simple. You need to take the annual revenue of your company, divide that by how many minutes there are in a year, and this will give you a dollar value per minute. So in the case of this, I think this was the Amazon example that I mentioned. Yeah, this was the Amazon example. In this case, they had about $107 billion in revenue divided by 365 days, 24 hours, 60 minutes per hour gives a downtime cost of about $200,000 per minute that you're down. So when you think about that, that should help the business set a scale and priority for how much they care about downtime. Now, as we go a little bit deeper into it, a lot of people on business, everybody in business knows that you want 5 nines of uptime. That's the standard. You want 5 nines of uptime. Well, most people don't understand what 5 nines of uptime means. 5 nines of uptime means that you get less than 5.5 minutes of downtime per year. And that's incredibly difficult to achieve. You have to have a lot of stuff working well. I just watched Ford versus Ferrari. I don't know if anybody just saw that movie, but so I've got the 24 hours at Le Mans in my mind. But that's a race where people race a car at top speed for 24 hours. You go over 3,000 miles, and anything can go wrong. If a tire blows, if a rod goes, if a seal goes, if the fuel runs out, if the driver gets tired, every single point across the entire thing is a single point of failure for the entire business. And a lot of services are that way. If your checkout doesn't work, you're not making any sales. If the front end website doesn't work, nobody can browse to even buy anything. So when you think about your services, you want to get to that 5 nines of reliability. And if you think over the last year, I mean, just reflect on this for a moment. How much downtime have you dealt with? You should actually have an idea in your head of what you're at in terms of how many nines you can guarantee. Even anybody that's been down for a day can't even make 99.8% uptime for the year. They're behind that. So this is incredibly difficult to achieve, and you should, and when communicating this with the business, they should understand that this is an incredibly high performance metric to reach. And you should have data for the last few years, aggregate data of how much downtime you've had that you can share to say, look, this is what we've done over the last 5 years. We spend and lose this much money every year to downtime. If we can invest a little bit more, maybe we need an extra head, maybe we need some extra tools, whatever it is, we can avoid some of this downtime. Maybe we need to do some re-architecting. It's going to be worth it because look, this is the dollar amount that comes out of it. In order for you to get 5 nines, you need all of this stuff to be working in concert. You need your continuous integration on point, which means you have a whole bunch of stuff underneath that needs to be working. Your integration testing needs to be on point, especially as you move forward with microservices. You've got 150 microservices. You need to understand how those things are going to work together and how failover is going to go into, which goes into the continuous delivery. Do you have a smart way of rolling out? Do you do canary releases instead of regular rollouts so you can actually catch changes, problems before they go out to general users and eliminate them? There's enormous cost savings in that. And your infrastructure needs to be on point. You have to have a good architecture. So if you're doing a single monolithic application that restarts every 20 minutes because it runs out of memory, that's going to be tough. You're going to have some downtime, and it's going to add up over the year, and it's going to add up into pain points. Now, some people might actually look at this, what I've outlined here, and say, you know, is it really fair to do annual revenue divided by minutes in a year? I mean, come on. I mean, if the website's down for 5 minutes, like people, maybe they just come back and they buy anyway. I actually think in many ways it underestimates the problem. Consider if you're using a service that goes down, you start looking for another solution, and you've now been biased against the site you're trying to use because you believe that it's not reliable. So that hurts your brand, that hurts the minds of the consumers. So even if those people do potentially come back to purchase later, they're now that much more likely to look at a competitor. So it is, if anything, an underestimation because it doesn't account for the future ramifications on your business. When in that Southwest example that I brought up, and again, if you're from Southwest, I'm not trying to call, this was several years ago, and I'm sure you guys have, you got it all worked out now, but when somebody couldn't travel for a whole day, are they going to keep using the same airline, or are they going to start looking for competitors? It goes that way. You have to be reliable. If you're not reliable, people are going to start looking at competitors. So this leads to a little bit of a feeling of tug of war between the productivity engineering of the side of the house and the site reliability engineering side of the house that I mentioned earlier. Site reliability, they're thinking, how do I keep this thing up? How do I get my uptime great? And the productivity engineers are thinking, how do we deliver code faster? Because we want the value, and we're going to talk about that in a second. This can feel like a big tug of war. In fact, they actually work together. If you want to improve your uptime, you should improve your code delivery. So this is the difference between people that do daily releases and quarterly releases, right? If you're doing quarterly releases or monthly releases or even weekly releases, you're basically packaging more and more changes into each deliverable, which means that each time you deliver the software, it actually has a higher risk because there's more stuff in it. The surface of what can go wrong is larger. And that means the deployments become more painful, they take longer, they require more resources. Now, in order to get to daily or several times a day, low risk, small changes, it requires a lot of discipline, and it requires a lot of planning, and it requires good tooling. It's a bit like if you think about, to go back to the Le Mans metaphor earlier, the racing metaphor, when they bring those cars in, because they're optimized for it, they can change the tires and the brakes and refuel in like 10 seconds flat because they optimize for it. Now, if you don't optimize for it, as we don't with our daily drivers, you have to take half a day off of work, go take your car somewhere, sit in a waiting room for an hour to get that stuff done, and then pay a larger bill for it. So you want to be in the mentality that releases are standard, happening all the time, and if you can get to the point where somebody can push a release at 5 p.m. on a Friday, and you have confidence that it's going to work, or if there is a problem that'll be automatically rolled back or whatever, that means you're going to be delivering a lot more business value. So this is actually what we're going to talk about next. So we talked about uptime. We're now going to talk about delivering faster, and I think this is one of the areas that people neglect often. Now, the first argument, the uptime argument, this relies a little bit on fear. So as you're talking to the business, you're saying, look, I want to give you 5 nines of uptime, and we better invest in it, because if we don't, this is how much money we lose for every minute we're down. That's a fear argument, right? Now, that's good. That's the same thing when you're talking about selling security. It's also a fair argument. Hey, what if we get hacked? This is going to be really painful. We better invest in this stuff, right? Delivering faster is a little bit different. So if avoiding downtime is the stick, delivering faster is the carrot. People are inspired to try to deliver faster. So what does that mean? So I love this quote. It was given during the presentation today by me. It is, unwritten code has the same value as undelivered code. And this is a great thing to remember. I would say as well, unmerged code has the same value as unwritten code, because if it's not deployed, it's not providing value. And most engineers don't think about this, but every piece of code, every line of code you write is delivering business value. If it's not, why are you writing it? Why would you write code that's not going to make something better, that's not going to make your service more reliable, that's not going to make people love you more, that's not going to deliver delight to your user? You're not going to write any code that doesn't deliver business value. If you're writing code that doesn't deliver business value, then you got to rethink everything. You're just wasting your time. You've got to write code that delivers business value. So if you think about it, every single software change has a dollar amount attached to it. It has a dollar amount that it's going to deliver. Now, some changes are relatively small. Maybe they only deliver $20,000 worth of value over a year. That sounds like a lot to some people. It's not. I actually know of, this was a great interesting study. This is a top technology company that I'm familiar with. I won't say who their name was, but they were working on a single change that was going to make the company an extra $10 million a year. And they could predict this because they had the kind of analytics associated with the change and the expected impact. So they knew that it was worth $10 million if they could get this code deployed. Well, that means that, and the analogy for the business side here is, undelivered software is just like inventory sitting on a shelf. And people from the business world, from the supply chain world, understand that if you have inventory, if you have stuff that you can't sell and it's sitting in a warehouse, it's just costing you money and you lose a lot of value from it. A lot of people, to take a different analogy, if I were to ask you, what is the most impressive innovation from Apple over the last 20 years? A lot of you might say the iPod. I mean, we're coming up on 20 years, come to think of it. A lot of you might say the iPod. Some of you might say unibody, notebooks, or you might talk about the App Store as a key innovation. These are all totally valid answers. But the one that people often forget is that Apple has the best supply chain in the world. They carry almost no inventory. I think they carry 3 days of inventory at any given moment. So when you order an Apple product, it updates the entire global supply chain within about 20 minutes. And that changes production schedules, how long shifts people have to work, what shipping's happening. All that stuff is baked in the moment you click checkout. And that means that they save and make an enormous amount of money because they can deliver stuff faster and carry less inventory. Software is the same thing. If I've got a change sitting there that can make us an extra $10 million and it's a year and it's delayed a week, we just cost the business a bunch of money. So if you can deliver software faster, it's going to make your lives much better. Now, we did a case study with Steelcase a while ago. You can view this on the site. There's a link there, where when they switched to CodeFresh, their code delivery cycle, it was specifically, I think, the code testing phase of the equation. It cut down by 3 days. It went from 3 days to 3 hours. So basically eliminated 3 days in their average code delivery, in their mean time to change, lead time to change. So what does that mean for the business? Well, if we were to take a rough estimate, now I don't know the business value actual numbers from Steelcase. They didn't tell me. So I'm gonna spitball here, right? This is okay. We're gonna make some guesses. Steelcase last year had $3.4 billion in revenue. It would be fairly standard for the number of engineers that they have, that the changes that they made in software delivered an extra $100 million in value over the course of the over the course of a year. which means that if we can reduce the delivery by 3 days, we make the business almost an extra $1 million, a little under $1 million, $822,000, just because we can eliminate delivering the code by 3 days. So if you can shorten that time, there's an incredible business value that you're delivering. So when you're talking about productivity engineering, the analogy that I always think of is an assembly line. If you can implement an assembly line so you can roll cars off every 5 minutes instead of having people hand make all the parts and deliver a car, once a month, that's a lot of value that you can deliver by just being faster. And when you're productivity engineering, when you're doing DevOps, you're doing productivity engineering, you're trying to find ways you can shorten the time that it takes for you to deliver code. So this is the screenshotable slide. If you have $100 million in new business value, you multiply that by 3 days saved divided by 365 days a year. This gives you the new revenue that you get for that value. So in this case, a little under $1 million a year was delivered because we were able to deliver software about 3 days faster. Now, depending on your business, this is going to be different. So estimating the business value of all of the changes you make in a year, that is somewhat difficult. As a rule of thumb, and this is a little bit, this is a number that isn't rock solid. This is going to be very highly variable for a business. But as a rule of thumb, if you take all of the cost of your engineering salaries and multiply that by 8, that should be roughly the business value that they deliver. Now, there are some questions about how that's amortized over time and why 8. Basically, I just looked at a sample set of companies and how many engineers they had, how much revenue they had, how much growth they had, and made a rough estimate of what the ratio is. Again, this is highly variable. For very low performance organizations, this is going to be lower. For very high performance organizations, this is going to be higher. If you're at Google, it's probably quite a bit higher. If you're at, well, I'm not going to give an example of a low performance organization. I've already made enough people angry by talking about downtime, so I don't want to alienate anybody else. Yeah, all right. So let's go forward a little bit more then. So lead time to change. So this, as I mentioned earlier, CodeFresh is really focused on this code delivery loop, right? We're a CI/CD platform. So we know that if we can shorten the time from when you write code to when it's deployed, this is where we have the most business value and what we built our business on. So this time period from code to deployment is your lead time to change. And this is a critical metric, and it's one that you should be tracking. So you basically take the time of the first commit that was made to when it was deployed, and this is your lead time to change. And if you can shorten that, now by itself, that metric isn't necessarily super useful. I don't know what you're building. Maybe you're building super complex stuff and it takes you 45 days on average lead time to change because just of the nature of your problem, of what you're doing. The question isn't what's the baseline, the question is how can you change it? So if it's 45 days, can I get it down to 40? Because if I can then take the business value, divide it by the time, and I now know exactly how much money extra we will make because we can deliver that business value earlier than later. So this is fairly simple for, I think, the business to understand, and I think that these slides can actually help you explain it to them. So feel free, of course, to use them. Now, number 3. So we just looked at an example of how we can deliver stuff faster. We looked at the example of how we can avoid downtime. Let's look at number 3, which is saving engineering time. So this one we're not going to spend as much time on. This is an example of cutting build times. So if you can cut build times by just 5 minutes. Now, if you've got 100 engineers and they're making an average of $1.25 a minute, and you should know how to do that calculation. You take their salaries divided by the number of working days, divided by how many hours they work a day, divided by how many minutes in an hour, and now you have the average value per minute, average cost per minute of your engineers. And by the way, your engineers are one of the largest costs in any organization from a human capital standpoint. Human capital is the business speak for people. In a people standpoint, your engineers are usually the most expensive part of a business. So people think of that as a cost center, but it's a revenue generating center. And that's what you have to make people realize. This is a revenue generating center of the business, and their time is very expensive. If I can cut just 5 minutes off of my build times, and let's say we're doing on average 5 builds a day, and I've got 100 engineers, they're making $1.25 a minute, I'm gonna save $780,000 a year just by cutting 5 minutes on average. Now, depending on your build times, 5 minutes may be easy to achieve, or it may be very difficult to achieve. It all depends. In our experience, and this is something that we focus on at CodeFresh, because we have optimized our platform with built-in caching, and we use SSDs attached for all of our pipeline, shared volumes, and things like that. We're able to achieve pretty awesome savings. Lots of times people that have 20-minute build times will go down to 4 minutes or 2 minutes even. And so that adds up over time. Now, if we look at a great example was from KubeCon, Ethan over at Hover. He actually shared that when they switched to CodeFresh, their build times went from 2.5 hours on average to 12 minutes. Now, if we apply our equation, now I don't know how many engineers Hover has, and I don't know how much they make, but Ethan does. So he can actually take this metric and he can say, this is how much money we just saved by shaving off hours of build time. Now, if you can just make 5 minutes, as I mentioned, especially as your engineering organization grows, the cost savings on this start to stack up in a major way. So by looking at it, and you can add up all these things, right? I'm going to avoid downtime. That's going to save me this much money, right? I'm going to be faster to deliver software. That's going to save me this. That's going to make me this much more money every year because I can deliver the business value faster. I can time shift the value, and if I can save some of my engineering time, that's going to save me this much money. You have a pretty good case for what you need to do with DevOps. So saving engineering time. One of the things I would mention just while I show this equation, a lot of people, when they run this, actually think only of the salaries, but that's actually the wrong way to do it. You should actually include the salaries, any bonuses, stock option grants, and the employment overhead. So any business, usually it costs 10 to 30% more than whatever the salary is for somebody in order to employ them. That's the cost of providing healthcare and benefits and 401k and whatever all that stuff is. You can actually get this from your HR. Ask them what your all-in cost for 100K engineering salary is, and they should be able to give you the variable, which you can then apply to your organization. So this is, and in a public company, you can actually just go get these numbers off of the public filings. You can figure out what the total all-in cost for your engineering organization is. So so this overhead should be included. I actually didn't include it in this calculation here. So this would probably be about 20% more depending on the organization. So it easily pushes over $1 million if you got 100 engineers. You can save 5 minutes. All right. So the fourth one is reducing infrastructure overhead. So this is one that we're also not going to spend a ton of time on, but it is one of the things that I'm pretty passionate about is getting people to go cloud native. This is getting people to adopt Kubernetes, containers, serverless, service meshes, these kinds of things. Now, being cloud native doesn't mean that it has to run on the cloud. It's actually just cloud native technologies. So if you have a cloud native application, it could actually be running on-prem. It could be running on somebody's phone. It's about how it's architected, right? So most organizations spend about 30% of their infrastructure budget just on machines running idle. Now this is something that's done because it's difficult to optimize monolithic applications, whereas more granular microservice-based applications are easier. So if you're using something like Kubernetes with microservices, not only can you do auto scaling, which means you don't have to pay for infrastructure you're not using, you can also do tighter packing. So each node that's added to the pool actually is packed tighter with processes going on than maybe a VM that's going up and down and idle in usage all the time. Also, if you're architected for it, and this is an investment, and this This is where your SRE, your site reliability engineers start to perk up a little bit more. If you can architect your application in such a way that you can use spot instances, you can reduce costs of architecture by 90%. It's huge. So I'm a big fan of cloud native, and I think that there's a huge business case that's very easy to make. And you can just take a look at your infrastructure budgets today and run an estimate of, oh, okay, if I can cut my infrastructure cost 30% and I get some more failover and reliability, so I can actually cut out some of the downtime, and I'm going to actually cut off some of the time that it takes for me to deliver the software because I'm using infrastructure as code. Well, now I have a pretty amazing business case for things that I want to invest in. If I need to add an additional person, I need to buy some tools, whatever it is, you've got the dollars and cents there, and you can stick them in front of people. So one of the themes from this is don't be afraid to put numbers on paper and estimate this stuff. And engineers sometimes struggle with this because they want to have an exact number. Well, guess what? It's really, really hard to get exact numbers sometimes. So spitball it. Make an estimate. Back a napkin calculation this thing and say, okay, this is based on the numbers. This is kind of looks something like this. Now there's a lot of variables in here. There's a lot of play in the joints. We understand that. But if you can save $3 million a year by having some better DevOps practices, you can be off by 40 or 50% and still have a pretty good business case for what you want to do. And it also swings the other way. It could actually be more value. So using some of these calculations in here should be valuable. All right, so this leads us into the next. Actually, I want to pause for just a second and just check out if I want to answer any of these questions right now before we move on. Oh, okay, yeah, actually, these are good questions. Yeah, let's save these for the end because I think these are great questions. All right, so another example. This is on the build versus buy. So this is actually one of the mistakes when people do make a decision. They've now looked at the business case. They've said, okay, I'm going to save this much money. I'm going to save this much money. We're going to make this much money more. I want to invest in this stuff. We're going to go build our own thing versus if we're going to go buy our own thing. Now, it may shock my audience to know this, but software vendors traditionally are in favor of buying versus building. I know you're shocked. So understand there is some bias there going in, okay? That is common, all right? Fair enough. But the thing that people usually don't account for when they're thinking about build versus buy is the cost of maintenance. Now, there's actually a really cool tool. I've linked to it here. It's bearmetrics.com/build versus buy. And what you can do is you can just put in a few metrics. I'm not actually calculate this for you. What you can see is that the cost to build this tool, now this is actually a real case study from a CodeFresh customer. I don't want to share their name because I didn't get their permission to share their name along with the numbers. They're fine with me sharing the numbers, but just not with their name. They actually had a hand-rolled deployment tool they were using, and they needed 2 full-time engineers to maintain it. And they needed to continue to invest in it over time, both to maintain it, but they actually needed to do additional investment to make it support Kubernetes and some of the cloud native stuff that we've talked about. So this was versus buying CodeFresh off the shelf. They were going to spend $47,000 for their license because of the number of engineers and the amount of builds and how much concurrency they needed. So when they actually sat down, people classically always underestimate the value of engineering time. It's actually very, very expensive. So in this case, it was going to cost them about $70,000 to build, and they were going to have to maintain it to the tune of about $200K a year. So when they factored that in compared to a CodeFresh license, they're like, we're going to save $250,000 by switching to this tool. Like, that's a no-brainer. We're going to save a lot of money. And the ongoing maintenance is going to be is really, really high. So when you're and I think somebody just said, well, management wants us to do this. Was that what you're saying? Management wants to do this. This is John. Management wants to do this. Dev knows this is the thing to do. Dev is being crushed by a huge pile of work to do and not enough time to do it in. So each are pointing to each other to get started, and nothing happens. How do I break the logjam? Well, honestly, lots of times these calculators are useful, right? Like, look, we've got this tool. We can just buy it. It already does the thing. And this thing isn't core to our business. Now, in general, as a rule, you do not want to invest in building things that aren't core to your business or won't be core to your business. So for example, I have no doubt that all of the people who are sitting here listening could build something kind of like Salesforce. Salesforce is very expensive. Why don't we just build Salesforce? Well, because it's not the key innovation for your business. Anything that you wouldn't end up either making money off of or turning around and selling to other people is not something you should build. Don't go build your own email server. G Suite, Exchange, they got that stuff figured out. They've already devoted hundreds of millions of dollars to building that stuff. You think you're gonna do a better job with 2 engineers? No, it's a bad idea. Deployment tools. I can build something on top of Jenkins, and maybe it requires 3 or 4 engineers to maintain, and it's a little hard to use and it's a little clunky. Or I could buy something off the shelf that's purpose built for what I already do. Again, it's going to depend on what it is, and so I'm not going to tell you that it's always going to be buy. Use this calculator here and run the numbers. And sometimes you'll run the numbers and it'll say, you know what? It actually is probably better to build this thing ourselves. And if it's strategic for the business, and I'll give you an example, Amazon famously built AWS because of the way they were architecting their applications and services. So they turned around and sold it. So it was worth them investing in because it could actually become a product that they could turn around and sell externally. If it's not something that you can turn around and sell externally, or it's not a key differentiator for your product, it's not something you should be building. It's probably something you should just buy off the shelf and move on with. Because you actually, and again, conceptually think about it, if I can take, let's take CodeFresh as an example. We're a CI/CD platform. A lot of people will try to hand roll CI/CD platforms internally. We actually just had, this is a case study where we should get out here soon, but Epic Games is a customer of ours. They have the most popular games in the world right now. They're incredibly busy, they're incredibly successful. They came to us a year and a half ago and said, we like what your tool is, but we want to build it ourselves. So they went and built it themselves. They came back a year later and they said, we really don't like our tool internally that we've built. We want to just buy something off the shelf that's good to go. Now, that was a lot of money and time and burnout on an organization in order to try to build it. And this actually goes to another point from a cost-centered standpoint. We didn't have this on the slides. If you can deliver software quickly, if you have awesome release processes, if you have high reliability, great architecture, as a software engineer, I want to work here. I want to stay here. But if we have crappy release processes, if it takes a long time to deliver software, if releases go poorly and I have to be stared at a screen for 3 days to make sure that it goes well, I don't want to work here. So you're going to introduce a cost in turnover because people don't want to put up with it. And if people don't think that engineers can't find another job, I mean, hello, this whole presentation is almost a business case for why you should pay your engineering more. Yeah, people are going to do that. So I think you just have to drag them to the table and just show them the numbers. Like, these are the numbers. So you can argue with the numbers. Maybe you can argue with the endpoints. You can try to poke holes in this, but we just ran the numbers. So you want to have a discussion about why we should build this thing when I can show you that it's going to save us $250,000 a year. What are we talking about? Because if you're just putting your finger to the wind and making a wild guess about how this is going to save us money, come up with a business plan. Because we have a business plan for why we should just grab this thing off the shelf and focus on building our application and focus on building our IP, right? Your IP is what's valuable as a company. Duplicating Salesforce is only useful if you plan to go compete with Salesforce. Don't go build Salesforce. It's a waste of your time. And as shocking as it is to say, they've already done it better than you're probably going to do it. So unless you're planning to go and compete with them, it's not worth you going and fighting. So good question. So in summary, and we're going to get into the questions here, the rest of these. Don't be afraid to put cost to paper. In business, you have to do this all the time. You have to make rough estimates about what the value of things are going to be. Don't be afraid to do those. Gut check them against your colleagues. I once came up with a number after being jet lagged and being up for 30 hours. That once I checked it with a colleague, he was like, "You are high. This is way wrong." And he sat and pointed out that the places where I made errors, and I corrected my numbers, and I got something better. So it's okay. Put something to paper, then you can at least knock it down and figure out what's wrong with it and make it better. DevOps is one of the most valuable investments a business can make. Again, what's your number one human capital cost? Who are your most expensive people? Your software engineers. If I can make their time more efficient, I'm going to save a bunch of money. Speak the language of business. Try to use dollars and cents. Once you put those numbers to paper, now, and someone brought up these log jams that you have with management. Once you put dollars to paper and you stick it in front of them, they have to deal with it. That's the reality. This is what it costs. This is what it will cost. If we're fine with that, if we think that there's some strategic value that we're going to gain from building this thing versus just buying it off the shelf, by all means, if you think that your engineers can't be better spent on your own IP, I question the business acumen of that person. I mean, that's rebuilding tools that already exist that cost not that much money. Yeah, it's a question. So use these equations. Again, they're only as good as their inputs, but I'd love to have your feedback as you go through this. Go have these discussions with management, and I want to hear from you. I'm on, you can find me on Twitter. I'm at Today Was Awesome. I should have put it in the slides. Today Was Awesome is me on Twitter. Come in and hit me up later and tell me how those discussions go. I'm happy to help you. As we get into the questions, just a shout out, we have a ton of upcoming events, more webinars, more content, most of them on the technical side, but sometimes we do these business ones. Codefresh.io/events. Several related webinars and presentations I would suggest you watch. CI/CD pipelines for microservices, incredibly valuable. Also talks about some of the business value just a little bit, but is more technology driven. Multi-cloud Canary with failover, talks about Canary releases, how to do them, how to perform them with Kubernetes, and some of the value that comes from that. And then using multi-stage Docker, Go, Java, and Bazel to destroy long build times. Sorry for the BuzzFeed headline there. Another technical talk on just shortening build times. I would suggest you check those out. So let's get into the questions now. And I will read some of these. So Mikhail, sorry if I said your name wrong, asks, and please send your questions in. If we are targeting to have 15 to 20 releases a day, what pain points should we consider upfront? Or, for example, metrics that will give us overview of value that we have brought to business. Okay, yeah, that's a great question. So what you're basically looking at is that time delay, right? So if you can deliver the changes multiple times a day instead of what's the alternative, daily or weekly? Well, if it's weekly, you cut an average of 3.5 days off of your deployment time. So take the overall business value divided by that 3.5 day, multiplied by that 3.5 days divided by 365, and now you've got a dollar amount you can actually associate with that specific change. So you just need to take the average, the deltas, and compare them, and then you actually have a dollar amount. Now, if you're targeting 50 to 20 releases a day, what pain points should you consider up front? Well, they go into all these things that have to work together. Slide back on slide 14 here. This stuff. All this stuff needs to be working in concert in order for you to get there. So your CI/CD needs to be on point. You need to have really good processes, and your continuous delivery or continuous deployment needs to be on point. So in other words, Canary releases, very valuable, because if you can automatically catch a failure and roll back without any human intervention, you're going to save a lot of potential pain. So your CI/CD, I think, is the most critical element in this. If you have really good testing, if you have really good integration testing, if you're doing security testing, you can start to automate a lot of these processes. Now, one of the cool case studies, there was a talk at KubeCon from Hover that I mentioned earlier, and one of the things they talked about is that they went straight to continuous deployment, that is fully automated releases instead of continuous delivery, where it's automated up to the point where someone has to say, okay, go ahead and deploy this. And they actually found that their organization wasn't quite ready because their developers weren't taking enough personal responsibility for the changes they were making. So they actually had to step back and go back to just continuous delivery as they train up the organization to say, okay, look, when you get to this point, you have to take responsibility for the releases you're doing, making sure that the testing is good. And this goes again into the business value thing. In that blog post I mentioned, such a great write-up from Michael Lynch, why he left Google. One of the things he talks about is that people were often rewarded for delivering new software that didn't have tests because they didn't throw errors, so their error rates were good. Okay, well, that's not something as an organization that you should put up with. That's really, really bad discipline. That's really, really bad discipline. You don't want to be there. Great question. Okay. Bird asks, how much time is wasted recovering from and fixing failed canary and blue-green deploys? Well, that depends really on how you're doing them. If you have fully automated canary releases that check error rates and automatically do a recover, you're certainly going to, and if that's happening too much, that means your testing earlier in the process needs to be fixed. The canary is there as the last resort. So saying, I don't want to do a canary because then I'm going to have to fix canary releases. Well, if I'm doing a lot of canary releases, that means my unit test and integration testing is not that good. So that's where I need to put my focus, because then your canary is going to happen less. The purpose of a canary release is not to test changes. The purpose of a canary release is to limit the blast radius of when something goes wrong. So you're going to save dollars on avoided downtime and avoided impact to users. But again, if you're having to always roll back, that means all of your changes are always bad. Your mean time to repair is going to shrink to like 0 with canary releases being fully automated, but your lead time to actually deploy is going to grow if your testing's not good. So that's why several of those metrics that I mentioned earlier, if you're tracking all those things, if this one starts to go down and that one starts to go up, you know that you need to go fix something to get this one to go back down, right? So so I think that's a good question. We already talked about John's question. Patrick asks, we've had our CI/CD pipeline in place for 5 years. Over those 5 years, we saw an exponential rise in deployments. Last year, for the first time, it leveled off. Now moving forward with velocity of deployments leveled, we need to focus on new metrics to justify DevOps in the organization. What are the big payoff numbers? I'm thinking SRE and maturing the practice in the organization. Okay, that's a great question. So basically you're saying we've already done a great job, and now it's hard to point at the continued value that we bring. That's a good problem to have. It means you've done a good job, right? You are going to have diminishing and ever harder returns. But this goes back to, let's look at, which one was it? It's this one here. Okay, on the 5 nines discussion, getting from 4 nines to 5 nines, which is just to cut out an extra hour of downtime, takes much more effort than it takes to get from 3 nines to 4 nines, because you're chasing an ever smaller window, right? So yeah, that is going to be a challenge. Your deploys now have leveled off. Now, does that mean that your build times can be continued to optimize? Maybe you can do more parallelization. Maybe you can do better caching. Maybe you can actually cut down on those build times. So there's still something to chase there. And then getting to the downtime component here, that's still going to be really valuable. So I think, yeah, the SRE practice of making sure that you have good reliability, good security, that's definitely an area of interest. And then there's going to be a maintenance cost to all of this stuff. So it's like, hey man, we've got to 5 nines of uptime. Great, now I've got to maintain it. This isn't a build once and forget it thing. This is a forever thing. It reminds me of when people are like, I had this budget discussion one time with a board member, and they said, well, once you've invested in building the website, then it's not going to be a cost going forward, right? And I thought, no, it will never be done. The website, the product, they will never be done. We will always be working on them. If they're ever done, I can't imagine the future state where it's complete. There's always going to be more work to do.